Hello students, in this video we will discuss the bank data problem that we had taken in the last lecture or last video. And in the last video we had imported the pandas as PD, and then we have read the loan data file in CSV file into the pandas data structure and then printed its content. We looked at the head and we looked at the shape of the data. Today what we will do is we will apply neural networks to this particular data. It's a small data of 10 records, so we cannot expect a very good result, but we will attempt to see that how neural networks can be applied, and then in the next video we will see that how this same program can be applied to a more complex data set that is downloaded from websites like Kaggle. So let us continue. So in this we are importing the NumPy. NumPy is a numeric array of the Python program, and that we are importing. Then we are importing the model selection class of sklearn, and in this package we are importing the train test split. Now basically this is used when we have to divide the data set that we are using into the training data and the testing data, so that both of them are not same and we can get more accurate picture of how the neural networks is performing. So if you want to understand what is training and testing data, you have to look for a video that explains what is supervised learning, what is unsupervised learning in machine learning as well as in neural networks. Then we have a pre-processing package, and in this package we are using the standard scaler. What this will do is, suppose our data is in hundreds or it is in thousands, it will bring all the data on a common scale so that the neurons can be applied to different data of different ranges. So it will normalize our data to a standard format. Then we have the sklearn neural network package, and from this we are using the MLP classifier class, which will be used for performing the classification using the neural net. And then we are using the matrix package, and in this we are using the accuracy score class, which will be used for finding the accuracy of the neural network. So as you can see here, we are reading the data using the pd.read CSV function, and we have supplied our CSV file, and then we have printed the loan data, and as you can see here in this cell, the data is being displayed. Then we are converting this loan data into an array, and in this array we are just taking the first three columns of the data. The data otherwise has 4 columns, but in this we are using only 3 columns, that is income, expertise and the credit score. The 4th column we will take as our labels or the classification classes, and therefore we are not including that in the loan data underscore NP. And this is a array format of the loan data. We have converted the data frame into an array, and then we have stored the third field, the third column, that is the last column, into the loan labels, and we have stored the first 3 fields into the loan data underscore NP. So we have separated the data as labels and the X variable and the Y variable. After that, what we are doing is we are splitting our data set into the training and the testing data using the train test split function. In this we are providing our X variable array, we are providing our Y labels, and then we are giving the test size, that is the testing data, what should be the size. So we are saying 40% of the data should be used for the testing purposes, and then we are giving a random state to our initializer or our train test splitter, so that when this is going to be applied, this will be the starting random point of our machine, so that the machine will be at a particular point when it starts performing the model for neural network. In this same state we will supply to the neural network also. As you can see here, random state 142. Both these states should be same to get accurate results. Then we are applying the standard scaler we have taken an instance of the standard scaler and we are transforming our X train data and the X test data using the scaler, so that since the data is in a very varied format, something is in 10,000, something is 1 lakh, something is 600. So it will bring all the data, it will neutralize the data on a common scale. Then we are applying the MLP classifier. In this we have taken hidden layers to be 10. Then activation function is ReLU. There are other activation functions also. Then solver is Adam, and then random state is 142. So if you provide all these parameters, you are going to get a accurate neural network design, and then you fit your training data which is scaled with the Y train, that is the loan status, whether the loan was granted or not. So this will fit the data and train our neural network, and as we can see here, we are getting a warning that even maximum iterations were reached, but still the network has not converged. That is why, because the data is very small, that is why we are getting this error. It's a warning basically. And then what we have done is, we are predicting for the testing data using the MLP dot predict function. So we are testing here, and then we are finding the accuracy score function we are using, and we are finding the accuracy between the predicted data and the test data that we have, test labels which we have earlier found, and we are getting an accuracy of 75%. So as you can see here, using this code, we can apply simple neural networks to our simple data. And in the next video, I will discuss how to apply it to a data from a website like Kaggle. I hope this video is useful to you. Thank you very much.